Hello and welcome to material science, or what you might also call, no, let's do that again. Hello and material design for Android developers. The point of this session is to try to get into some of the technical details and the overview of what it actually looks like from an engineer's perspective. There's a lot of design sessions this week, including one right before this session, where they talk about some of the ideas behind material design. What we wanted to do is talk about what that means in terms of the actual APIs we're exposing, or where you hook into this stuff as an Android developer to create material design applications. There's a hashtag if you like to do that thing. There's a feedback URL if you have absolutely stunning and glowing comments about the session. Please feel free to go there. If you want to know what we look like, you could actually just look up at the stage, or there's pictures of us. I am Chet Haase.
And I am Adam Powell.
And we are both on the Android UI Toolkit team. This is the team that basically handles the UI Toolkit widgets down through the graphics that render them with animations that move them around and spitting out the GPU commands to actually hardware accelerate all this stuff and get it onto the screen as fast as possible. That's what the team does. Which means that all the stuff that we need to implement for material design also needs to run really fast, because the same team is handling the functionality as well as the performance aspects, which is an interesting trade-off.
Right. So the first question that you might be asking is why? So we've already seen the keynote videos. We see a lot of flashy effects. We see high-minded design. We see performance challenges. And we see a way to really bloat our UIs. So we don't actually want to take that sort of negative view of this. We want to make sure that this is something that really sort of matters to our users. And if there's one big takeaway from all of the material design material that you're going to see over the rest of the day and for probably until the L release here as everyone starts getting their apps ready, is that motion matters. Movement can teach a user what something can do and where it came from. If you've ever seen in a UI something just pop out of nowhere, something disappears from out from under your finger, that's a really frustrating experience. So by using motion, we can go ahead and teach users how the system behaves and what they can expect from that system. So this is cues. We can give cues about what can be touched and moved by making things that look tangible. This is one of the things that cards really give us. And these sorts of virtual objects that can morph and move around in ways that don't quite simulate real-world objects can still hint at that tangibility. These are your cards, paper and ink, all of these things that you've seen in the videos so far. So the takeaway really is motion plus tangibility equals a more understandable UI for your users.
So I wanted to give you a brief mental model of what this release and this process of actually implementing material design was to me. Actually making this work within our team, getting the stuff, the pixels actually showing up on the screen that represents the design. The process is basically taking the ideas that UX has, that the design team has, where there are these grand ideas, and there's paradigms, and there's systems, and there's languages, and there's all this nice stuff that they come up with, and then actually translating into the technical details of the functionality that engineers actually need to write applications that are going to deliver that. So the way I picture it, so we have this huge design team, so we have access to great artists, and we could ask them to come up with art that sort of represents this, or I could actually just draw it myself. This obviously is an artist waving his hands furiously and coming up with beautiful rainbows and wonderful things. You can tell it's an artist because there's a beret involved. Either that or they're French. So we take the design ideas that are sort of floating up in the air and incredibly vague when engineers get in the room and get a really puzzled look on their face, kind of wondering what all this stuff is. When they say language in the context of applications, it doesn't make sense. So then
that means Java, right?
I think so. I think it means the Java programming language. We'll talk to the UX team after this and sort of nail that down. But the idea really is to take the concrete elements and figure out what they actually mean by all the hand waving when they're talking about floating action buttons, when they're talking about ink and paper, and actually translating it into the particular elements that we need in the platform to give you those capabilities. The way I think of it is, I think it's like the Nyquist sampling theorem says that there's a frequency at which you can sample a curve such that you can then reconstruct the original curve. And I won't get into technical details because I don't understand them. But It's the same idea here. If UX is creating this beautiful spatial curve of the design language and the pattern they're coming up with, and what you want to do is implement enough functionality that they actually get what they wanted, even though they had a hard time sort of describing it in terms of the crisp elements that you needed. So what we did on the toolkit team was to translate that into the features and the functionality that we needed to expose those capabilities. And this boiled down to the features that we're going to talk about in the next few minutes. We have the ability to do real-time shadows. We have activity transitions with shared hero elements. We have circular reveals. We saw some of that in the design talks as the floating action buttons are revealing into larger morphed content. We have RecyclerView widgets for more animated and rich list capabilities, touch feedback, so the user has constant feedback about what's going on in the UI as they're interacting with it. And then obviously we're working on performance all the time as well.
So from all of this, how do you actually write a material app? Well, the first step is something that you're probably already familiar with in writing Android apps, is your theme for your activities. So theme.material is the first step. Choose this, inherit from it if you've already got a custom theme that you're using other elements in, and just take a look. How does your app look with this just simple switch flipped? And you're going to need to make some spot fixes to that. Pretty much every major app that's non-trivial at this point has done a lot of work to try to match either a hollow theme or a very custom theme that's been implemented in the past, and you're going to need to update those individual elements as you go. So you'll want to go ahead and implement the design guidelines. So this is going to be new ways of dealing with layouts and colors, new metrics, new measurements, and use of the grid. From there, it's really mostly standard Android programming. You're going to be using a lot of the tools that you're already familiar with there. We've got some new APIs to assist with motion and alignment of certain elements on screen that you traditionally haven't had a lot of control over in the past, such as where things are positioned in the action bar. And then, of course, you can use the support library as needed. Most of you are familiar with this already. We've got things like drawer layouts, view pager, all of these widgets that developers know and love at this point. We're adding in some more. We've got RecyclerView, which we're going to talk a little bit more about shortly, and CardView, which basically wraps up a few of these pieces of new functionality in L and gives you a nice fallback for a particular use case on older platform versions. So then, as needed, you can go ahead and use some of the exclusive L APIs for newer platform versions as well. This is stuff like newer graphics APIs around shadows and clipping, setting elevation on your views so that they can pop out into space. We've got the touch feedback ink ripples that you've seen in some of the videos so far. We've got icons and other drawables. You can animate state changes. If you're already used to pressed states and focus states, so on and so forth, you can define animated transitions between those states now. And as for general animations, we've got view reveals. We have new ways of dealing with animation curves, and of course, the activity transitions that you've seen. So at this point, most of you are asking, what about compatibility? Because no one has the luxury of targeting only L and above right now if you want to have some users when this thing ships. So for apps on previous releases, use the app compat themes. You may already be familiar with these from using the compatibility action bar in the support library. We're going to be expanding this out to also cover the material design components in L. You can, of course, still use the new support library widgets regardless, like RecyclerView, CardView, and the others that you know and love.
So now let's talk about some of the new APIs and functionality that we exposed in the UI toolkit. One of the important points that Adam was talking about is you can get a lot of the functionality of the design that you're trying to achieve just through standard Android programming, by which we mean the APIs that you're already using, standard layout and measurement stuff, standard drawing stuff. We did add new APIs. Most of the reason they're there is actually for our internal use. So we have the ability to pop a view up to give it elevation above the view hierarchy plane. But we use this for some of the standard widgets. You don't necessarily need to use these for your application, but they are there for your use if you want them. So one of those areas is actually widgets, which this is not new L APIs. It's in fact even better than that. It's new support lib APIs.
Right. So again, you have access to this from everything from API 7 and above. We have both RecyclerView and CardView available for you to take a look at early in the preview. So what is RecyclerView? You've heard a lot about this now. It's a base class for new adapter-backed views. Basically, anyone who's tried to do anything remotely interesting or complicated with a list view at this point has banged their head against a lot of walls, hanging beams, sharp objects, whatever you might want to use as your metaphor for that. And basically, list view is set up to take complete and total control over the layout of items pretty much any time at once. So you look at it funny and everything relays out, all your animations are lost, views that were halfway through an animation are now halfway off screen, bound to some other data item. And it's really frustrating as a developer to try and use that to get any sort of really rich experience. It's really outgrown its complexity budget in a lot of ways. So RecyclerView is meant to have more flexible views into these large data sets that you would traditionally use a list view for. We've already built in functionality to allow an adapter to tell the widget a bit more about what's going on with a data set. When items are specifically added or removed, or when ranges of items are specifically added or removed, rather than just saying, hey, my data set changed. Well, what changed? I don't know, you figure it out. So in this way, we're able to give you a few more things automatically, such as animations when items are added or removed from the set.
If I could avoid creating one more tutorial on how to animate something in an adapter view, I will be happy.
So that's the idea here. So we also allow you to do custom layouts in this framework. Many of you have said, OK, well, list view is great, but what if I want it to scroll horizontally? What if I want the dividers to behave just a little bit different? What if I want a staggered grid that doesn't necessarily line up along particular lines? Also, so we offer that. We offer multi-directional scrolling. Basically, you as the developer can plug in your own layout manager to define how item views get laid out. This sort of speaks to the general theme of RecyclerView, which is to make it extensible in all the ways that list view really wasn't. We also have card view. Now, card view takes a little bit of a different approach from RecyclerView. RecyclerView is meant to be a very generalized component that you can go ahead and build on, whereas card view is meant to be something that solves a very particular use case in a way that is compatible and gives you a best effort approximation of the design intent on different platform versions. So in this case, we'll give you a standard consistent look. You get the real soft shadows and customized rounded view clipping for your rounded corners and such on L. And we'll go ahead and give you a best effort faked version and shaped background pre-L. But as you can see from the slides up here, these actually look pretty similar in terms of giving you the general intent of the design. So this type of tool is the sort of thing that we want to provide more of to allow you to express material design on older platform versions.
So now let's talk about the other side, the APIs and functionality that's actually in the L platform. The previous stuff was in Support Library. Feel free to use it wherever it makes sense for your application. If you're targeting certain functionality for your application specifically at L, then you have access to the new APIs that we introduced. First of all, let's talk about shadows. So here's an early video that the UX group did as they were exploring the space of what they wanted the shadows to actually be like. So we can watch this. Let's see if it runs. So we have the light source. Notice it's an area light source. We have an orthographic projection for the camera looking straight down. And then we have cards doing complicated things, casting these nice real-time dynamic shadows. And all the engineers responsible for implementing something like this at 60 frames a second just had a heart attack.
Or sometimes laughed. Much.
So here's my favorite video mock that came out of the design team during the entire release. A couple of the engineers that were working on early prototypes of the shadow stuff went over to talk to the design team, and as they were talking to them about the requirement for having this area light source, and maybe it should be rounded, maybe it should be rectangular, and we definitely want rounded corners and soft shadows and all this stuff, and obviously it has to perform at the 60 frames a second rate. In the background was a high-end workstation running high-end animation software rendering this, one single frame in 30 seconds, and they want it 60 frames a second on a phone. It's just so painful. Just that you can't even tell where the shadows are there, and it's still taken this long to render the thing. And we're wondering how to actually do that in real time. And then I guess we figured it out. So the idea behind shadows is to allow you to elevate your views, to post those views above the view hierarchy plane. So you can think of everything prior to L living in a volume, if you will, except that everything was at z equals 0, right? Everything is in that same plane. It's basically the flatland of Android. Well, in the L release, we allow you to then boost some of those views at your option with an elevation or a translation z value or a z value to basically give them a z value that puts them above the plane of everyone else in that flatland. And that allows them to then automatically cast the shadow from the area light source that we have positioned locally above that world. One other advantage of doing it this way, instead of just trying to figure out, okay, well, how can we quickly draw this shadow image behind this thing and make it look approximately correct? One advantage of doing it correctly in this sort of view volume approach is that views can also draw outside of their container bounds. I don't know if you've ever tried to draw a view, like cast a shadow or scale the view up, and all of a sudden it scales or it casts outside of its containment hierarchy, then it gets clipped. And then you have to play around with this API called set clip children false, and things kind of go not the way you expected them to. And it's all horrible hacks. So instead of doing hacks, we're actually doing it physically correctly. We're creating this 3D volume. You can boost views up there, and they can draw wherever they want to in that volume. And they're correct, ordered in Z. They draw in the correct order, and the shadows draw in the correct order below them on top of the view hierarchy itself.
So in addition to that, many of you have probably run into cases where you really do want to have a proper Z order for your views when you start stacking them. In the past, you've had to override the child ordering parameters for drawing. In the past, you may have also just sort of abused the general child ordering within a view group in order to achieve the desired effect. And this gives you a very easy way to skip all of that hassle.
So we can look at some of the APIs involved with doing this. There's the basically elevation property. This is where that thing lives. You can think of this as its permanent Z location. And then we have a couple of other properties that are similar to the translation X and translation Y properties that we already had. These are more for use in animation, sort of transient post-layout state where you're animating to and from different Z values. So for instance, if you have a view that you want to pop up, you want that shadow to enlarge, when it's in a press state, then you would animate the translation Z property, whether or not it had a positive elevation value. There's also other APIs we're not showing on the slide about clipping. So you can set the shape of the shadow itself. So you can think of floating action buttons as being this circular shape. Well, they want to cast a circular shadow. Otherwise, the illusion kind of breaks down, right? So there are APIs to allow you to set the shape that it casts a shadow from. There are also APIs to allow you to set an outline that it's actually clipped to. Some of this necessarily, given the constraints that we're operating under, are very limited. You can't clip to arbitrary path shapes. So some of the details are in the SDK docs, and also the APIs around clipping and specifically are probably apt to change as we go toward the full release, but you can see where we're at in the preview release in the meantime. Let's run a demo so we can see how this thing works. So if we can switch to the demo, here we go. You can see next to my very red finger, I can drag this card around, and I can actually enable tilt. And you can get a subtle tilt on this thing. I think there's even a little bit of shading, which is probably way too subtle for these projectors. So you can see, yay. This, in fact, is not an artist rendering, and it's not taking 30 seconds of frames. We got 60 frames a second on, this is a Nexus 5. Actually, a lot of the early work was done on older and slower devices. I think the original Nexus 7 was used as a prototype device just to make sure the things were actually going to be fast enough. And again, this is an area light source. For any of the graphics geeks in the room, area light source, local, right? There's a lot of assumptions you could make if it was a point source and it was infinite, and we're not making those assumptions here. We're actually creating these meshes in real time to cast shadows with soft boundaries because that's the effect that they wanted. So works reasonably well. There's another one I was going to show. Let's see, shadow card stack. So you can see these stacking elements as they're popped up to different Z values, and they cast larger or smaller shadows just as you would expect in this physically correct volume.
And this demo really illustrates some of the other effects that you may have seen during the keynote demo as well, which is you can have elements that are part of the same merged plane split and take on more of a three-dimensional character as you interact with them.
If we can switch back to the slides. Hey,
You're set.
there it is. Yeah, let's talk about touch feedback. Sure. Let's talk about ripples. So one of the things that we wanted to do in the UI in general, actually we were thinking about it in the engineering space before we were faced with the overall design language changes for material design, is the ability to tell the user more of what's going on with their UI interactions. In particular, when they press a button, there is that immediate atomic interaction where the button is in a press state, so they get the press state color. That's nice, but wouldn't it be nice if we could animate some of those changes so they get information about the changing state, sort of a time-based change in state, as well as more information about where that state actually changed. So ripples do that. The touch feedback interaction on the standard widgets and on your custom widgets, if you choose to enable it, gives you feedback about a press state happening or other states happening. So the ripple will sort of emanate, not only that, but it will emanate optionally from the point of contact. So you can get a ripple that actually starts from where the finger pressed. So much more interaction information for the user to actually understand what's going on.
And again, just to speak again to the principle of motion and how that's really sort of helping understand the UI, this eliminates a lot of the really disruptive flashing that you see in UIs today, where you get the entire rect of the touch area lighting up very harshly as soon as you touch the slightest corner of it. This sort of softens that out a little bit for your users.
So there's a new class called RecyclerView that enables this, and this basically wraps the content that you want to display, and then reveals that content over time with the ripple. And then you optionally have a color that you can set as well to change the properties of the ripple. This comes automatically built into a lot of the standard widgets like buttons. You'll see this in the applications that are enabled with material design already. Or you can use RecyclerView directly, either from code you can instantiate it, or you can do this in XML resources. Or an easy way to do it is you can set the foreground or background of something to be a selectable item background, and that will automatically ripple that selection interaction. So we had some changes in icons. We had some new stuff added. There were a couple of these. One was StateListAnimator, which is the ability to actually animate through different PNGs. You can think of this as keyframe animation, where we're just flipping through different images along the way. The checkbox and the radio button, I think, in the L preview release represent this. So if you've seen any of the demos of that so far, if you want to actually flash the system image, you'll see those widgets interacting through this. It's basically a way for us to animate from state to state through this series of images along the way. And the other one was StateListAnimator, the ability to say, okay, when this widget goes from this state to that state, here's this arbitrary animation that I want to run. In general, you would create, you would give it object animator animations, as you see here. We're stacking up 3 of them in an animator set, and we're saying, okay, I want to animate the following properties on my object when I go from the pressed to the unpressed state, and back and forth and to different state combinations. So a much more flexible way of saying, here's the behavior that I want this widget to go through as it goes from state A to state B.
So what's an example of where someone might use that?
For instance, popping a button up. If you want to have a press state for when you click on the button, that sounded like a canned question. It wasn't. I wasn't expecting you to ask that. Like, why are you making me think up here? So if you want a button to raise, to set its elevation property when someone presses on it, then you can set an animation to do that. So when it gets into the press state, it says, I'm going to the press state. Here's an animation that I need to run, and then you would animate the translation Z property from, say, 0 to 20. And then when it goes back to its base state, you would animate from 20 back to 0. Animation. Let's talk about animation. So there were various things introduced in the preview release, which you'll see in completely different areas, and we'll sort of build up to the largest one. The reveal animation that we've seen in some of the floating action button demos in the previous talk, for instance, as well as other interactions that are up to you in your application, is the ability to define an expanding shape that reveals the content underneath it, like a circular reveal, or you can combine this animated circular shape with a more complex shape of your view to get sort of a rounded rect effect or whatever. Basically, you say, create this animation that is a circular reveal. It's going to be centered here, and the radius is going to animate from this value to that value, and then you start the animation and you go. So very simple way to create an animator. It's kind of an opaque interface. There's not a lot of flexibility there. Again, given the constraints that we're under to actually make these things performant on the types of hardware that we have, we limit these capabilities to the specific use cases that we find are important. So you can do what you need to, but it's going to be limited to this set of capabilities for now. The important thing to realize, though, is that some of these things can be expensive. So one of the things that we wanted to do was not make it super easy for you to just create this arbitrary clip on your shape and leave it there all the time, because that is incredibly expensive. The way that we implement this stuff through the GPU is not trivial. So we're going to run an animation over time, and then it's going to be done, and we can just be back to rectangular views, because frankly, that's easier. So it is expensive. We expect you to use these in very transient situations where you're just animating a thing, and then you back out of the animation. You can get a similar effect on previous releases. If you've used the search on the Nexus 5 and the KitKat release did this, they had a circular reveal to show some of the search results. There are ways to do this already. Again, there are performance issues there, and you need to figure out whether that actually works for your application and your situation. But you can already do it with drawing shapes with bitmap shaders. Animation curves. So one of the things that the designers as well as the engineers wanted in this release was the ability to have more arbitrary time interpolation. So we already have the ability. In fact, the default behavior of all animations is ease in, ease out. So we have a subtle acceleration and then a subtle deceleration out of it, and you can tweak how magnified those effects are. And there's other things. You can accelerate all the way in. You can decelerate all the way out. But once you get past those, that's kind of it. And designers really like to think of things in terms of curves instead, quadratic and cubic Bezier curves, and the ability to tweak the parameters to get exactly the kind of timing behavior they need. So that's what we implemented in the platform. And in particular, there's 3 animation timing curves that they recommend as part of material design. And you can see these here. They define these with particular curve parameters, and we then define them. I put the file names down at the bottom. So these are resources that you can simply refer to as interpolators in your animations. Or you can actually set the parameters arbitrarily. So you can see that here. There's an XML resource that you can define to do this, or you can access the code directly. You're basically working with a unit square. This is sort of a traditional animation and graphics way of defining things. You have a unit square from 0, 0 to 1, 1. You can think of the control points being at 2 corners of that square. Those are the anchor points, sorry. And then you define where the control points are to vary that curve along the way. In fact, you can have a much more arbitrary path, because we're actually doing a full-on path in there. It's not even just a single curve. You can define a complex path. I don't know why you would, but you can. We also have the ability to curve motion now. You could already do this. I wrote a blog post, I don't know, 2 or 3 years ago, talking about how you could use type evaluators to move things along in a spatial curve. It was not easy, which is why I wrote a blog post around it and explained it, and you can certainly still use that approach. But we also wanted to enable an easier way to do this through the API. And now you can. There are new constructors in Object Animator that will allow you to specify the path that you want an object to follow as it moves along, animating both X and Y as part of the same animation. So there's a path animations demo in API demos. So if you check out the SDK, check out that demo, and it'll show you different variations on that theme. Activity transitions. So this was a fairly big effort that built on the transitions API that was introduced in KitKat. The idea behind transitions is to make animations much more easy and automatic. They're still customizable, but the big idea is I'd like to know what state my UI was in, and then I want to know what state it's going to be in, and I want you to animate everything in there instead of me creating custom animations for everything, right? So you snapshot where things are at, and then you run layout, and right before it draws things, you figure out where things are going to be, and then you roll everything back and you animate those changes instead. That's the way transitions works, and that's the API that came out in KitKat. And this is the way that activity transitions now work as well. It builds on that same model, but allows you to have that same way of specifying animations between activities. And not only that, not only does it figure out how to animate these things out from the launching activity and how to animate the items in on the launched activity, but you can also specify a set of shared hero elements that are then basically thrown over the wire and said, OK, this image was here, and now it's going to be there, and it's going to be this different size, and animate that change automatically. So we came up with a protocol for defining, OK, here's the name that we're defining for this thing, and then the activity on the other side, if it knows what that name is, can make some assumptions about that being the same element. Then that element is shared across and animated automatically through activity transitions.
So the summary for that is essentially that this now gives you a way of establishing a protocol between different activities that may or may not be part of the same application to share a particular element in a transition from one to the other.
So you can already do this in your own application. Like if you have a sub-activity, say a details view for some thumbnails, there is already a technique for doing this. What we're doing is making that less of a hack and more codified in the framework APIs to allow you to do that more easily inside your application. Not only that, but through the protocol we've established with the names of these shared hero elements, you could actually do that across processes. You could end up launching somebody else's activity, and if they know what to do with that shared hero element, then they can take part in that activity transition animation. If you want to know how to do it on previous releases, if you're trying to do this everywhere, there's a dev byte on it called custom activity animations. And you can think about the technique that's used there as basically being sort of baked more into the framework as a first-class citizen of how to do it for real.
Right, and this will take care of a lot of the really tricky bits around the activity lifecycle itself. If your activity gets restarted, make sure that you're not replaying another intro transition animation that you don't want to see again, so on and so forth.
So here's some of the code. There's actually a lot more APIs and code involved, especially when you start customizing things. But just to give you an introduction to how you enable these things and how you actually start these animations. So you can put this item in your theme. You define a style that says, I want to enable these window content transitions, or you can do it in code, very similar. And then you can either just use the default animations, which are going to cross-fade between activities, just a simple fade-out, fade-in. Or you can set custom transitions, either ones that you define or ones that the platform gives you. Like, I want an explode transition, which shoves everything out off the top and the bottom or the sides of the screen. And so you can set these customs for the exiting activity as well as the entering activity. And then finally, you can define what the shared element set is that you're passing over the wire, give it names, pass it over, and then define what the transition animation is that happens on those elements as well. And I think, we have a demo in a minute. Finally, I wanted to mention that there are new transitions that were written as part of this work. These are available for transitions in general. There's the ability to move image. It's a lot more flexible. Image view can be a little bit cranky when you're trying to sort of resize it along the way, and this has some capabilities to allow you to do things in ways that you probably want to if you're scaling or moving images around on the screen as part of these transitions. Sliding effects to slide things in and out to the right and the left. Exploding is sort of exploding the items out with this staggered delay, so you get a nice effect of things sort of gradually moving off the screen. And a couple other transitions as well, but let's take a look at a quick demo. If we can switch to the demo device, back out of here. So this is in API demos. This is just a simple demo that shows some of the how-tos. So the items that I'm clicking on, obviously, are the thumbnail images that then end up launching this other activity you're going into. They share that as the shared element. You can see the other images animating out, and then the list items, the text animating in on the other activity. And then, this is a demo that was written as part of another talk. At 2 o'clock, we'll go into more of the details and some of these graphics goodies. And again, you can see as we press on this thing, then it launches this other activity. And we go into the second activity, sharing the thumbnail, sharing that bitmap image is the data that's being passed over for the shared hero element. If we can go back to the slides. Take it away.
Take it away. So the takeaway for this talk is that we're going to provide you with the material look and feel for all the basic parts of the framework, all the buttons and checkboxes and everything else that you know and love. We'll give you the ability to theme these, so you can go ahead and apply your branding colors to these without having to auto-generate a lot of extra assets within your application. But that's really not enough. What you really need to do is to work with your designers, work with the design guide itself, and you're still going to be writing a lot of custom code in your application, because the parts that make your application really stand out and be different are the parts that we can't write for you, or else they're going to be the exact same things that every other application does. What we want to do is make sure that you have the tools available in order to make those really unique experiences for your users. So, resources.
So there's a few resources that are worth mentioning. You've probably seen this one already. There is a design spec. Is it there? There's also there's a link off the d.android.com to a bunch of this information. And you certainly want to check out the preview site itself. Get the SDK, build against it, get the system images, flash it onto your device, play around with it. I would also suggest, if you're interested, especially in the graphics and animation parts of what we talked about, you come to a talk at 2 p.m. that coincidentally has me on stage again with Romain Guy. And we'll go into a lot more technical details about how some of this stuff works and how it might be used to create these kinds of applications. And finally, there's a feedback URL again, and we actually have some time for questions. So there are a couple of mics. Find a mic out there and fire your question at us.
Come on up. Yes?
So a quick question. I want to know how we're going to be able to access this in previous versions of Android. I know I can look that up, obviously, but I want to know how much of this is supported in the support library and which version of the support library.
So there's a new version of the support library out with the Preview SDK right now that's going to make some of this available. But really, the Preview SDK is more about showing you some of the new APIs in their natural habitat. And for a lot of other reasons, you're probably not going to want to let some of the apps linked against the Preview SDK out into the wild, just because it's going to be involving a lot of other pre-release API. That being said, once the final SDK version is available, you'll see that the app compat library and others will have some of the backports of some of the visual styling that's available. And we're going to continue offering things along the lines of card view to do very specific use cases, and then things like RecyclerView that will allow you to bring that kind of motion everywhere. Now, things like the activity transitions that Chet spent some time talking about, that you're probably not going to have available. So we're probably going to just go ahead and have some simple fallbacks that you probably already know and love there.
It's also important to note, as it came up earlier in the talk, that a lot of what we're talking about is an approach to design that you can then implement using standard Android programming, right? So yeah, some of the new animation capabilities, if they're not part of the APIs on the earlier platforms, you can't use them. But there are other ways to achieve those kinds of effects in many cases. And some of the measurement, the layout, the colors, that stuff, you can get stuff to look very similar. It's just going to be a little different approach for some of the new animation capabilities in particular.
That's right. The microphone in the back?
Can you hear me?
Yeah.
Yes.
Good. So in the keynote and in some demos that I've been seeing, I've noticed that there's been a movement to circular image views. Is that going to be an available widget for us to use?
Yes. I don't remember if we made it just a simple drawable or an actual view, but we've got a component in the support library that will go ahead and apply that circular clip to your images.
Oh, there's a rounded bitmap drawable in the support library.
Yeah, I think that was
what
it.
you're talking about?
Yeah.
Yeah, I mean, it's fairly simple. We did not create a floating action button or a fab widget because it's pretty darn simple. It's basically an image view where the thing that you're drawing is a circular image. Fairly straightforward. You set an elevation on that, you tell us what the outline is, and we do the right thing with it. It's similar for card view, actually. I wanted to mention this, that it's very easy to actually get a card view effect. In fact, the demo that we're going to show in the talk later today, I just implemented using a standard view that I clipped and I shadowed appropriately. It was straightforward. The advantage of us baking it into a specific widget is at least we have standard padding and layout, and also the ability to have that similar look and feel on earlier releases. So that seemed worth creating a widget for. The fab, not so much.
Okay. Thanks.
Yeah.
So the activity transactions and everything are really nice and definitely solve a common pain point. What I wanted to know is if there's any support for that for fragment transactions and things going across fragment boundaries.
Yes, I don't believe it made it into the preview SDK.
Yes, not yet, but yes. As soon as we solved the really hard problem, which was activity transitions, the next step was fragment transitions. So I would look for that.
Thank you.
Yep.
In the back?
Oh, he had the same question I did for
Oh, okay.
activity trend. So, but we can expect to see that in another preview release, maybe. It's in the
I don't know what the timing is of other bits coming out. I would just say expect to see that in L.
Okay, but you're working on it. Awesome. Thanks.
So now that we're having these elevation transitions for objects, kind of implies manipulability of things on the screen. Are there any improvements to drag and drop coming in L as well?
What kind of drag and drop are you looking for specifically?
Oh, reordering collections kind of arbitrarily, you know.
Oh, I see.
Nice event interface.
Yeah, so one of the things that RecyclerView lets you do is it lets you apply some item touch listeners that basically lets you it lets you handle touch at the level of the collection rather than the level of specific item views. So you don't have to perform a lot of the translation back up to the parent and then back down to specific points in space for that. So hopefully that'll be much easier.
Yeah, that's exactly what I was hoping for. Thanks.
Great.
In back?
Does it make sense, or is it even possible in existing code to change list views to recycler views?
So they're largely compatible. There's just one mostly, well, two key differences. First is that if you're used to cursor adapter and the way that it splits out create and bind view into two different steps, this is the default state of being in RecyclerView. So as long as you can sort of split out those components of your get view from your list view adapters right now, then that's one easy thing to do. The next piece is, like I mentioned before, being able to supply richer notifications about the nature of a data set change. So without getting those sorts of signals rather than just a very coarse-grained notify data set change call, then we're not going to be able to do quite as much with the animations.
Is that the only benefit then?
Which, the animations?
The richer notifications.
It's newer. It's cooler.
It should be obvious, right? No, I guess I don't quite understand the question. So from some of the stuff that we had talked about before, we've got, do you mean benefits of switching over the
Yes.
adapters or switching from like a list view to a recycler view?
Yeah,
For what's essentially the same UI?
Yes.
Okay, yeah, if list view is still meeting your needs, then by all means, don't do any more work than you already have to. This is mostly to address the needs of any sort of UIs where you really want to be able to do much more intricate motion and intricate touch interaction with your items, or if you want to do custom layouts.
Great, thanks.
What do you guys think about the relationship between these new styles and basically how it relates to overdraw and battling overdraw? Because from my point of view, it seems not overdraw friendly.
Do you want to talk about some of the work that we were doing with some of the drawing command reordering? Because I think that some of that comes in.
Yeah, I mean, we wear many hats in the toolkit team, and one of them is all about performance. So there was a lot of work done in previous releases about optimizing display lists and eliminating overdraw as much as we can automatically, actually in the framework. So it used to be the case that if you had, let's say, a view that was completely obscured by another view that was larger than it and completely opaque, we're going to overdraw that thing because we don't know what's going on. If you want to draw that, okay, we'll draw it for you. And all of a sudden, you've got 2x overdraw without doing anything. So now we can actually eliminate that because we do some post-processing on the display list so that we don't draw the thing that's completely obscured. So there's a lot of intelligence going into the display list optimizations already to avoid some of those situations. I would agree that more animations and more rich graphics on the screen probably means that you need to be aware of what's going on. If you're having fading and translucent effects all over the screen all the time, then yes, we will be drawing more pixels than if you didn't do that. It's kind of a standard Android programming technique, like be aware of what's going on the screen, use the tools that are there, like the overdraw detector, to actually show what's going on at the pixel level and make sure that you're not tripping over those hazards.
Right, in practice, we've seen a lot of teams start building their material UIs so far, and by and large, their overdraw situation hasn't changed a whole lot from their previous designs. Again, as soon as you start introducing fully opaque backgrounds, sliding over other things, if you start doing a lot of stacking, then yes, there's cases where you're going to want to start thinking about the overdraw a little bit more and what you can do to avoid the clipping. We're definitely trying to do as much as we can in the framework to do that automatically.
I guess from my perspective, it's more of the design principles of everything feels like it's stacked. And in order to accomplish that, you're going to have to stack things sometimes. And is there a good way to get around that?
So I would definitely say limit how deep
stacking is more of a transient state. I haven't seen a lot of UIs where the things are full-time stacked on top of one another.
Well, there's some of the things in like the Google Now cards that'll stack on top of one another, so on and so forth. But even some of those, what they've started to do is you'll notice that some of the cards start merging together into a single card if it's part of a collection that then breaks out into some of their detail views. And I think that some of that was shown in some of the demos as well.
Okay, thank you.
And it looks like we have 2 seconds left for questions, which means that we're all out of time. Thank you very much.
We'll be over here if you want to ask some other questions afterwards.